talk about divisibility. The definition of divisibility or divisible is a whole number is divisible by a second whole number if the first number, the dividend, can be divided by the second number, which is the divisor, and you get a remainder of 0. So let me say that again. A whole number is divisible by a second whole number if you can divide the first number by the second number and have no remainder. So these are some rules that you want to know. Write them down and keep them handy. For the rules of divisibility, we can say that a number is divisible by, and these are our specific rules that we have. A number is divisible by 10 if the number ends with a 0. For instance, 540 ends in a 0, and so that means that 10 will go evenly into it with no remainder. And you can see where I worked it out here. But just by looking, if the number ends in a 0, it's divisible by 10. Here's another example, 13,670. It ends in a 0, so we know that 10 goes into it. A number is divisible by 5 if it ends with a 0 or a 5. So think about it. When you count by 5s, 5, 10, 15, 20, 25, 30, 35, 40, 45, and so on and so on. Notice every one of these multiples of 5 ends in a 0 or 5. That means anytime you see a number, if it ends in a 0 or in a 5, it can be divided by 5 with no remainder. So looking back at these two examples, 540 ends in a 0, and so we know 10 goes into it. Well, we also know that 5 goes into it because for 5 to go into it, it has to end in a 0 or a 5. 13,670 ends in a 0, and for 5 to go into it, it has to end in a 0 or a 5, and so we know that it is also divisible by 5. Let's move on. A number is divisible by 2 if it's an even number. Let's recall what even numbers are. Even numbers are like 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and so on and so forth. Odd numbers, 1, 3, 5, 7, 9, 11, 13. Basically, an even number is any number that ends in a 0, 2, 4, 6, or 8. And an odd number is any number that ends in a 1, 3, 5, 7, or 9. So, we know a number is divisible by 2 if it ends in an even number, or if it's an even number. 674, 4 is an even number, so we know, without even having to work it out, that 2 will go into 674. 5,290. 5,290, this 0 makes this an even number, and so we know that 2 goes into it. We also know that 10 goes in because it ends in a 0 here, and we also know that 5 goes in because it ends in a 0, and a number that's divisible by 5 ends in a 5 or a 0. How about 12,465? This is not an even number because it ends in a 5, so this is an odd number. That means it cannot be evenly divided by 2. However, since it ends in a 5, we do know that it can be divided by 5. So, a number is divisible by 2 if it's an even number. A number is divisible by 3 if the sum of the digits can be divided by 3. Now, let me show you what I mean. That's a little different. The sum of the digits can be divided by 3. So I have 207. If I added those digits together, 2 plus 0 plus 7, I get 9. So the sum of those digits is 9. Does 3 go into 9? Yes. So 3 goes into 207. Now we could work it out to prove that. And if we needed to, and if the problem we were doing required that, well then we would. It goes in 69 times. So, but just by looking, you can tell if 3 goes into it by taking the sum of the digits. Let's look at 1,089. We take the sum of the digits, 1 plus 0 plus 8 plus 9. 1 plus 0 is 1, plus 8 is 9, plus 9 more is 18. Does 3 go into 18? Yes. So 3 goes into 1,089 because the sum of the digits is 18. 3 goes into 18 6 times, and so 3 goes into 1,089. Let's look at this larger number, 21,738. Again, I take the sum of the digits, 2 plus 1 plus 7 plus 3 plus 8. Okay, 2 plus 1 is 3, plus 7 is 10, plus 3 is 13, plus 8 is 21. Can 3 go into 21? This is why your multiplication facts are so important, because you should know, yes, 3 goes into 21 7 times. Since 3 can go into 21, then we know, without having to work out a problem, that 21,738 is divisible by 3. Well, the rule for 9 is very similar. The divisibility rule for 9 states that a number is divisible by 9 if the sum of the digits can be divided by 9. So instead of being divided by 3, we check to see if the sum of the digits can be divided by 9. And if it can, then that number can be divided by 9. So let's go back up to our examples here. 207, the digits added up to 9. Does 9 go into 9? Yes. So 9 goes evenly into 207. How about 1,089? We added those digits and we got 18. Does 9 go into 18? Yes. So 9 goes into 1,089. And finally, 21,738. The sum of those digits was 21. Does 9 go evenly into 21? No. So 9 does not go into 21,738. And here's a divisibility rule for 4. A number is divisible by 4 if the last 2 digits by themselves can be divided by 4. So when I have the number 728, I just look at the last 2 digits. I don't add the last 2 digits together like we did with 3 and 9. I just look at them. Does 4 go into 28? Yes. So 4 goes into 728. How about 72,920? Look at the last 2 digits. Does 4 go into 20? Yes. So 4 goes into 72,920. And look at this gigantic number, 5,763,136. Does 4 go into that? Gosh, I don't want to have to work it to find out, but I don't have to work it to find out. Look at the last 2 digits, 36. If 4 goes into 36, and it does, then 4 goes into 5,763,136. By the way, another one that I didn't put down, I'm going to put down now, is if a number ends in 2 zeros, like 500, if the last 2 digits are zeros, then 4 will go into that as well. Now, why should I know all this? Well, unfortunately, or I don't know, I wish that maybe we had known this prior to starting this school year. And I think some of you did learn the divisibility rules. This is kind of just a refresher. So what good does it do me? Well, with what we're doing now, here's what good it does you. Let's say I were going to multiply fractions, and I have 6/17 times 7/3, and I want to multiply the numerator times the numerator, which is 42, and the denominator times the denominator, which is 51. And then if I need to look at this and see if it's in simplest form, and I don't know, multiplication facts, very good, but I hope that you do. But this isn't a basic multiplication fact that we've learned, but I can test rules for divisibility. I can say, does 2 go in? No, because they're not both even. Does 5 go in? No, because they don't both end in a 5 or a 0. Will 10 go in? No, because they don't both end in 0. How about divisibility rule for 3? Well, I add the digits together and see if 3 goes in. 4 plus 2 is 6, and 3 goes into 6. 5 plus 1 is 6. 3 goes into 6, and so I know that I could divide the numerator and the denominator both by 3 to put this into simplest form, unless there's another factor greater than 3 that will go into both, and I don't believe there is in this case. Now suppose you have this gigantic, not very attractive fraction problem, and you were to have to multiply these numbers together to get your answer. Yikes. Well, let's use our divisibility rules to see if we can do some cross-canceling or simplifying before we multiply. Look at the numbers diagonal and determine if there's some factor besides 1 that can go into both of these. Well, looking at 55 and 40, I noticed that one of them ends in a 5 and one of them ends in a 0, so I know that 5 will go into both. So 5 goes into 55 11 times, and 5 goes into 40 8 times. So I was able to simplify. Looking at these numbers diagonal, I'm not sure. I know 5 doesn't go in. They both are even numbers, so 2 could go in. But let's see if there's something larger that goes in besides 2. Well, let's do our divisibility rule for 9. Let's go for the biggest one we can. It doesn't end in a 0, so we know 10 doesn't go in. 1 plus 0 plus 8 equals 9. 3 plus 6 equals 9. So I know 9 will go into both of those. And so I can divide 36 by 9 and I get 4. And 108 divided by 9, I might have to work over here. And that's all right. And I see that it goes in 12 times. Well, I do notice that 4 and 12 can also be reduced again, but at least I've gotten myself down to smaller numbers using my divisibility rules. So the divisibility rules can be very handy to use to help you simplify fractions, to help you cross-cancel before you multiply, and there's just a multitude of uses. So keep the divisibility rules handy. Try to memorize them. It will help you in a lot of math areas.